Welcome back to Detailed, an original podcast by RCAT. This is the show where we uncover lessons learned to help you navigate your next project. I'm Cherise Lakeside, Senior Spec Writer at RDH Building Science, and your host. My guests today are Tim Lankau and Ethan Wong, both co-CEOs and founders of Hive ASMBLD, and that's Hive ASMBLD, based in Houston, Texas. Tim began his professional career as an attorney in the construction world before immersing himself as a thought leader in the 3D printing and construction innovation space. Alongside partners, he founded Hive ASMBLD, aiming to tackle the housing affordability challenge by combining robotics, prefabrication, and advanced material science. At Hive ASMBLD, Tim leads the development of 3D printed homes and oversees groundbreaking initiatives that underscore his commitment to equitable, innovative homeownership. Driven by the belief that every family deserves a safe, affordable place to call home, Tim's vision is not just building houses, but to shape a sustainable, resilient future of homeownership. Growing up in Silicon Valley, Ethan was surrounded by innovation and quickly developed a passion for building, whether it was Legos, rockets, or early tech prototypes. Growing up in Silicon Valley, Ethan was surrounded by innovation and quickly developed a passion for building, whether it was Legos, rockets, or early tech prototypes. He created a location-sharing app that predated Snapchat maps. Say that 3 times fast. And later studied mechanical engineering at Harvard. At Harvard, he joined Icon as one of its earliest engineering hires, gaining hands-on experience in advanced construction technologies. Now, as co-founder of Hive ASMBLD, Ethan is reinventing construction from the ground up. Alongside co-founder Tim Lankau, he's developing a 3D printing-based building system designed to radically reduce costs, improve quality, and empower crews to construct homes faster and more efficiently than ever before. The project we're talking about today is the Red Rock House, located in Red Rock, Texas. The Red Rock House redefines what's possible in modern home building, merging 3D printed construction with prefabricated panel technology in the scenic Blue Sky Estates community. Once an untouched 2-acre parcel, the site now offers a peaceful retreat less than 45 minutes from Austin, where sweeping views and natural tranquility set the tone. Now, let's get into the details. Welcome back to Detailed. My guests today are Tim Lankau, founder and co-CEO, and Ethan Wong, co-CEO of Hive ASMBLD, hoping I said that right, based in Houston, Texas. We are chatting today about the Red Rock House located in Red Rock, Texas. Tim and Ethan, how are you doing today?
Doing well. How are you? Thanks for having us on.
It was 7 a.m. here, so I'm trying to be awake. I don't know what time it is for you guys. But I'm excited to talk about this project because this is a little bit different than a lot of my interviews, and I love different and new, and I want to learn something. So we always.
And
Go ahead.
I'm doing well as well. And just title wise, we don't use the term founder at our company, but to the extent that there are founders, it would be both Ethan and I. Ethan founded a company and I founded a company, and we merged them together in 2024.
Okay, well, duly noted. And so I will make sure I also change the online script so that it shows that.
Right.
I always start with an icebreaker question just to kind of get to know you a little bit and get us warmed up. And so the question for you guys today is that I'm insanely curious about. So, Tim, I saw in the bio that I have for you that you were formerly an attorney. And Ethan, I saw that you studied mechanical engineering at Harvard. And so the first place my brain went was, how did the two of you end up here? I mean, it just is that, especially the attorney part, but even the mechanical engineering. How did you end up working in the 3D construction built environment?
I was a I was in construction prior to being an attorney, and then I went to law school, worked at a big firm for a while, worked at a smaller firm. In the meantime, all throughout, I was always doing spec build projects. So I've been in and around residential construction for 20 some years now, and always been uniquely interested in the new and the different and the strange ways of building things. So um, I got keenly interested in construction automation in general probably about 10 years ago. In the meantime, I had left law practice to start uh, another company with some of my clients. That was a behavioral health company, and we grew that company to a pretty big size. And my arrangement with the folks that I started that company with was, if I support you in starting this company, um, then you should support me when I start my construction automation company. And so that's it. All worked out well so far, and that's been my pathway here.
Yeah. And for me, I was a college student looking for something to do, and I realized I didn't want to go into big tech and work at Google or Meta or any of those businesses. And everybody was focused on software and the digital world, but no one's focused on the built environment and the physical world and hardware. You know, maybe other than Elon Musk, but he's not building houses. So that
Right.
left one big opening. And this was in around 2018 when I saw all these articles coming out about 3D printing and the potential of 3D printing. And then I was an early employee at Icon in Austin. And that's what got me into this space and this industry and the whole potential and message to, for this to be able to solve affordable housing is what really resonated with me and got me excited about this business. And then once you see the robots and the systems working, you're pretty hooked. So between that and the potential of this industry and where it was at, combined with the really cool designs and architecture that you can create with 3D printing, it was a no-brainer.
So, some of our listeners might not have a real understanding of 3D printed instruction. I still have a hard time, even though I know what it is, wrapping my head around how that works. Can you, just to help educate our listeners, give me just a basic definition of exactly what 3D printed construction is and how it works?
So 3D printing is it's a form of additive construction. So additive manufacturing. Additive manufacturing is the process of taking a raw material and producing a kind of customizable finished product through in one step. So 3D printing is one form of that, and probably the most prolific form of that. And so what we do is we use a s- a concrete. It's a concrete. It doesn't use Portland cement. It uses a pozzolanic cement replacement that we developed over the last few years. But it's a concrete slash mortar that we mix through a custom mixing system that we build, and then we have an industrial robot that lays that concrete down layer by layer to produce basically a concrete wall or a concrete structure that we then finish off with a panelized building system for roofs and things like that.
The way
You
that
call
also
the
the way
red.
that works
Oh,
in
go
theory
ahead.
or in practice is more like icing on a cake. So if you think about, icing a cake, that's essentially how you 3D print a house, but with concrete.
I, I've already got like 30 questions running through my head that are not on my list. I'll probably throw a few in there. So you call the Red Rock Passive House a hybrid 3D printed home. Explain that to me.
Um, so we, yeah, I mean, all our homes are hybrid in the sense that not every piece of the house is 3D printed. So there are some portions of the home that don't make sense to 3D print right now, primarily the roof, because yeah, in some parts of the world, concrete roofs are pretty common, but they're not really necessary here. So we have Ethan has um, a slick panelized system that we can use for the roof and elements that we don't 3D print. Um, so we'll call that a hybrid. I mean, all 3D printed houses are hybrids in
For
that sense.
now.
There's no such thing out there in the world as a 3D printed house that doesn't have, wood frame construction or something else for roofs and closets and some interior walls and things like that. Ours is a bit of a different species of hybrid because our vision is that whatever we don't 3D print is prefabricated. So we're trying to kind of marry the best elements of on-site automation via 3D printing with off-site automation via prefabrication. And I'll let Ethan speak to that because the prefabrication side is kind of his world.
Yeah, so I think Tim nailed that, but eventually in 5, 7 years, we'd love to have a fully 3D printed home where, everything in that home is 3D printed, and there's a lot of different materials that we'll need to use to make that happen, but that 3D printing architecture as a complete building and a complete structure is closer than we think, and we'd like to be the ones who make that happen. But the way that Tim and I have combined our systems and the way we really collaborated in the first place is that I was working on a prefab system, which was essentially a Lego kit for housing. And, it was lightweight. There was no wood. It was all composite and metal. And it was designed to really speed up the building shell process. So we're not creating a system and a product to replace the entire home, but to really provide all the functional space and the engineering, uh, so that after you have your building kit, it's a very simple way to add your finishes and complete the home. But we saw a lot of potential combining this this panelized prefab kit with 3D printed wall structures to where we can create this new type of building and new type of home in a lot less time at a lower cost and increasing the performance of everything. So our vision is that there is going to be a lot more automation both on site and off site when it comes to construction and building houses, and the ability to completely design and engineer a building kit will make it will facilitate that process to make it faster and easier to build. And so these prefab components really marry well with the 3D printed wall systems, and there's a lot of potential to finish all sorts of structures and complete buildings that you couldn't build otherwise.
Yeah, and there's a deep science between when it's more efficient to use an additive manufacturing process versus when it's more efficient to use a traditional manufacturing process. So in the manufacturing world outside of housing, in construction, you'll see things like injection molding and cast and die manufacturing, and then you'll compare that to additive manufacturing. And there's all kinds of economics and studies that go into, when is it appropriate to use an additive process as opposed to a traditional process. And there's factors that go into that, things like how what type of product you're building, how customized does the product need to be, how difficult is it to produce and ship in one central location versus having kind of miniature factories that are using the additive process closer to where the product's going to be consumed. And so when you go through that analysis in construction, invariably you're going to find that certain parts of the process are going to fall on the pure additive side where we should be 3D printing, this either on site or very near site. And then other things are going to fall on the efficiency line of we should be producing these through a more traditional process off site. But the whole point is you're bringing the manufacturing process into the construction process, and we're trying to convert the construction process into more of a traditional automated, not traditional, but an automated manufacturing process somehow, because that has to happen at some point to avoid this ever spiraling cost disease that's in our construction industry right now. So that there's the only way to solve that inevitably accelerating cost disease is to automate. And that means we have to begin manufacturing our buildings like we manufacture everything else in the world.
Yeah, and these are both tools for the home builder. These are tools that help the builders, build more efficiently, build faster, and be able to build more homes with the same amount of people. And at the same time, you're also getting a better, more customizable product at the end, and better in terms of stronger and more energy efficient.
Well, and if you can build a home faster and more efficiently, you're also saving money, which I would imagine with Ethan, with you talking about, having an interest in creating more affordable housing. We all know what housing costs are looking like,
Mhm.
and especially young people. Um, I like my youngest son. I wonder, with all of the college debt and everything, how long it'll be before he can even think about buying a
Yeah,
house with the costs of construction spiraling the
yeah.
way that they have been.
Well, if he's on
I'm
Pacific time like you, the chances of finding an affordable house are much lower.
Yes. Oh, they are over here. Down the entire West Coast. I'm in Oregon. He lives in Seattle.
Mhm.
Um, and that's frustrating, to watch, for our children, that it's going to be that difficult
Mhm.
for them to
Yeah,
get
and
there
it's not a
because of the costs.
yeah, it's not by any stretch a regional problem. This is a worldwide problem. So, we get contacted every day by people all around the world, and they all have the same problem with the rising cost of construction, which obviously raises the cost of housing. Um, there are we are already building at some significant cost savings through this process. I think we might be the only 3D construction company doing that right now. Most of the other ones are still a little bit higher than traditional methods, and selling more of a premium product. But we have an 80 home project in Houston where uh, we're selling the homes in the low 200s,
Wow.
and there's over um, $125,000 in subsidies going back to the homeowners. So um, in those we have those folks getting into these homes in the mid 100s.
You're not getting a shack in Oregon for in the low 200s. Just out of curiosity, do you think someday in the future this kind of technology will be usable for large buildings? I know we're talking about homes today,
Yeah,
but do you think that it'll get there someday?
absolutely. And
It's already being done.
yeah,
Oh
I
well.
mean, so one of our there's a company called Allquist that's doing Walmart extensions right now. So these are big warehouse type buildings. We have on our wait list dozens of warehouse type buildings. Um, it's perfectly doable. It's whether or not if the project makes sense for us right now, but yeah, it's perfectly doable to do larger buildings.
So one last question before we get to the actual house we're talking about, but I have to know. I'm pretty sure you don't run into Home Depot and pick up this robot. Um, I don't imagine these things are readily available. Where do you get that technology to do? I mean, I looked at some of your videos. I do more homework beyond what you send me. And so I watched an actual wall being built on one of the videos. Where do you even get that robot?
We build them. So we have a couple partners that we work with that we design them with, and they help us build them. But most of our equipment we've built either with a partner, and we've used a few, or we build from the ground up.
Wow.
There are commercially available 3D printing robots out there. So far, our experience with them is they don't work well yet, and the support chain for them is not there yet, and the logistics chain is not there yet. And the printing mortar we've developed, which is probably our most important technology, the robot is, it's not too difficult an engineering challenge to adapt an industrial robot to run a 3D printing toolpath. So that's done in a lot of industries, and that's generally technology that's available to those that want to go out and find it. The The bigger issue is trying to marry the very imprecise nature of concrete with the precision that a robot wants to work with. And so, really, it's the printing mortars, the mixing, and the pumping technology that's the harder part. And because what the materials we use are so unique, they set in like this concrete setting in under 2 minutes. So it's just a world different than any other substance out there. I mean, we're printing a wall in like 30 minutes, like 10 by 10 feet. And then after within 5 minutes of it done printing, it's strong enough to lift and move and install somewhere. So there's no setting curing time, but that brings a whole host of challenges that you have to develop kind of really custom equipment for. And that just doesn't exist out there in the world. So Ethan and I, we have in-house engineering, we engineer it, we test it, we build it, we change it, we test it, we build it, we change it. And this is a very iterative process to get to a system that works efficiently.
Well, I would imagine something that sets that quickly, you got to get it right. There's no room to have your robot make mistakes if it's setting that quickly
Yeah,
without
the
just
robot
having to
almost
redo
never
it.
makes mistakes. It's gonna follow the tool. Robots are very smart and very dumb. So like they do exactly what you tell them to do, and nothing more, nothing less. So yes, the mortar is designed. The whole system is designed to everything that mortar touches to be disposable. Because if you miss a beat in cleaning it or flushing it or something like that, then it's just a big solid rock. So um, we have a really specially designed system to where anything the mortar touches is something that if we make a mistake or where we just throw in the trash and attach a new pipe or a new hose.
So let's talk about this house. Um, let's just begin with a description of the overall design vision and scope for this project. Tell me what this house is going to be, and just a broad description.
So this was really a concept house to, take what we had learned on the first dozen or so projects that we'd done. It was a combination of, smaller casitas and ADUs plus a couple custom homes that we had done where we realized that there was a true performance and functionality and design aesthetic benefit that we could provide with the building system we're working with, combining 3D printing and prefab components. And so, we had done a lot of projects in the Texas Triangle, but in slightly more rural markets. And we wanted to do something a little closer to a major city. And so this house is only 45 minutes from Austin, and it was designed to be a real showpiece in terms of what we could do in terms of functionality, uh, you know, cost and design features, and for pursuing that passive house standard, to show really what the potential of the system can provide, on all of those fronts. And so this was designed to be a really cool, really energy efficient concept home to show what the future of 3D printing and home building really looks like. It also in a really great setting. So it's at this subdivision called Blue Sky Estates, minimum 2-acre lots, and you've got sweeping views of the hills and, great sunsets and all of that. So, it's a cool house in a even better setting.
How big is this house?
What was
It's going to be about 4,200 square feet. So it's a big house.
Wow.
it got a
Yeah.
little bigger through the
The
design process.
Yeah, we did just a month ago. We had built out we were building out the house, and our contractor that's doing the roof framing, just called us like, there's so much extra room up here, in the attic. We should go ahead and make that a room and so for an extra office. And so we said, go ahead and do it. Um, the advantage of using the SIP system is that we're insulated up to the roof line on all our buildings, so we don't have to have uh, unconditioned attic space. So it's kind of like you might as well use it since you're conditioning it.
So go big or go home, right?
That's right.
On
I
this
This
mean,
is
house,
that
Texas.
yeah, it's on this house. I mean, yeah, it was just kind of a might as well thing. But the other thing that we're kind of in the evolution of this house was we built a big custom house, and we had been testing kind of the energy efficiency of the wall system, and we were getting really good numbers without spending a lot of the extra cost and time and energy um, that you would do to get those numbers, because the 3D printing is naturally energy efficient because these are big monolithic concrete walls. We use a special lightweight concrete to fill the walls in that has some good insulation properties to it. And they have just so much thermal mass so that they really do take advantage of that thermal flywheel effect, like you're building with an adobe or stone. And we're getting that without a lot of the extra costs. So when we talked to the passive house people, we said, like, hey, as a concept, getting a certified passive house is typically a very expensive proposition, um, with all the bells and whistles that they want. We think we can get there basically doing what we're doing already, just with a few tweaks, a little bit thicker walls and things like that. So, so that's we said we should try it. We should try and see if we can get to those numbers that you're looking for the passive house certification without spending an extra $150,000 in triple studded walls and, you know, all the stuff that they normally want for a passive house.
So I'm curious, what are some of the unique considerations that you need to be thinking about with a 3D printed home that you might not have to even consider on your typical stick built home? You know, I'm sure the construction process on one of these homes looks very different. What are some of the important factors that you need to get right in this type of construction?
I would say that the biggest consideration is with the all the guts of the home, your mechanical, electrical, plumbing. That's the biggest consideration because you have concrete walls. You can't just punch a hole in the drywall and, change something if you put the shower in the wrong place. So that's really the biggest design consideration, but it's nothing new to home construction. Everyone in Europe and most of Asia and Latin America, lives in concrete homes. So this is new to America, but not new to most of the world that already builds with concrete. So there are some, design considerations and construction process considerations to make sure that everything goes in the right place and it's designed according to spec and built the right way. But that's it's not new to construction. It's just new to the states.
There's you want to be a little bit careful the way you do your foundation to make sure that it's properly supporting the weight of the walls, which are heavier than a framed wall. I think Ethan's right about the mechanical and engine, the mechanical and electrical, having that pre-planned appropriately so that we run conduit in our walls to run the electrical inside the walls before we fill the walls with that lightweight concrete. So once the conduit's in there, it's not going to move around. So we want to future proof it, provide more outlets than would be typical maybe in a home, because it's going to be difficult to add one. The conduit that we put in the walls, we oversize it. So if you ever want to run a different type of wiring, or for Cat 5, or whatever you're going to do, whatever it's going to be around in 30 years for the next type of wire, it's easy to wire and replace. So there's some future proofing thought from the idea that the walls should be there for 1,000 years because they're solid concrete walls. So um, that's of all the things that people say, hey, what are the disadvantages of living in a concrete home? The one that the one that I don't have an immediate answer of, this is not really a disadvantage, it's an advantage, would be, well, it's going to be difficult to remodel. Now, so I tell people, design the house that you want on the front end, make sure it's going to be flexible as you grow, because you're not going to want to knock these walls down. It's going to be difficult. The flip side of that is it's difficult because they're really strong, and isn't that the point of a house anyway?
So I'm curious about the design, working on the design side of the industry. Um, what exactly does a design look like for a 3D home? And when I say that, typically your drawings and specifications, contractor takes those and they build whatever on them. But you have this hybrid construction. And so does the actual design for this home, like for instance, do you do a model in Revit that can speak to the robots? Or is it a traditional design model, drawings and specs, and then you have to go then feed certain pieces of that into the robot? I'm assuming your design has to talk to both, obviously, people and the robot. So how does that work?
Yeah, I mean, it's pretty straightforward. We have a 3D modeling program that can import a CAD or a Revit or a SketchUp model, and then it will convert it into, um, it'll slice it and convert it into tool paths for the robots. And then we have an augmented reality application that you can put on and see all the tool paths and the robot movements, kind of projected into the real world. So you step on your foundation, you put your goggles on, and you see everything in the house projected into uh, projected through augmented reality, and then that also tells that program kind of allows a back and forth between the robot and the human operator. The robot's kind of saying, "Hey, move me here first, and then here next, and then you know this." And then as the robot prints the house, it kind of fills in the projection of the house as it's being built. But all this is done as automatically as we can do it. And we try and lean as hard as we can into artificial intelligence to really automate this process. And we that's moving quickly. So every day that moves a little bit faster. We're not too far away, and the end result of this is going to be that you're going to sketch up a sketch of a house on a napkin. You're going to take a picture of it, and the AI is going to come in and do your architecture and your engineering, and then create the instructions for the robots to build the house. This is happening with or without us, but it's probably, I don't know, 2 or 3 years away from getting to that level of automation on the design side.
So does that mean that in your opinion, I work with architects and engineers all day, every day. Architects and engineers education is going to have to change. Are they going to have to become a lot more tech savvy than they
Well,
are
the
right
engineers
now?
already are. Yeah, the engineers already are. I mean, most of our structural engineers, I mean, they're using AI empowered programs to do the bulk of the initial pass engineering work anyway. So we're just integrating that. And then architecture is coming along as well. So the idea of taking a basic design and translating it into full set construction drawings, that's very ready for artificial intelligence to take over. And I think most architects understand that. We work with a lot of architects, and we get a lot of calls from architects that understand that their profession is going to change rapidly. And a lot of the bulk work, the drafting work is going to be taken over by AI. The that's not We're not the ones doing that. That's out there in the world. The AI architects and the AI engineers, that's progressing faster than we can ever progress it. We're the bridge. So once you have all that intellectual work being done by AI, it still has to translate it into the physical world, and that's where robotics and AR step in. So we're hoping for a very seamless transition in a seamless world where AI can, you know, do the bulk of the work in designing and engineering the home, communicate that work directly to the robots so they can then put it into the physical environment.
And people relying more on software and computers is nothing new. So, people in construction who have to adapt to that are not going to be blindsided by any means. I think the other piece that people in construction will want to get a grasp on is the other building methods and other building materials that are out there, and just increasing their awareness of what building systems are, and what's out there. It's not just stick framing for residential and then concrete and steel for commercial buildings. There's going to be a lot more options as far as materials and building systems and building products go, and there's really a lot of innovation happening in the space. Both due to affordability and the cost issue, and also on the climate and sustainability angle with recycled materials and new composites and other lightweight solutions. There's a lot of wood replacements out there too, where there's potential to be much stronger and lighter and cheaper than steel, but with many different forms and shapes because it's a wood based product.
Yeah, and I would say that when you look at the larger world of construction tech, what we got first was the software because that's what Valley knows how to produce is software. So we are now overwhelmed with BIM tools and project management tools and logistics management tools. So like if you're in construction, your inbox is full of everyone. Every day you're pitched some new software tool that's supposed to help the construction industry. What's lagged behind is the harder part, which is the actual technology that actually builds things, that physically builds things. So that's going to be robotics in some way or another, or some. Well, it's robotics whether they're working on site or working off site in a factory. So when we're talking about the traditional manufacturing process, the key to unlocking the efficiencies that can bring to construction is it truly automated? So there are lots of prefabricated building technologies that still rely on framers framing the home in a factory in pieces and bringing it out. Kind of in my view, that's missing the opportunity of truly automating the process. You're industrializing the process. So you've moved from 1920 to 1945, but you haven't automated the process and got it into 2025, which is going to be through the use of various types of robotics and machine automation. So that's the frontier that's lagged behind, and that's the 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 part that we're trying to fit in as best we can.
So, Ethan, you mentioned sustainability and climate, and we're all thinking about that in this industry a lot. And it's becoming a bigger and bigger part of building designs every single day. Um, so you're uh, trying to design this house to passive house standards. Can you tell me what more specifically you're doing in this home to meet those standards? What different assemblies and systems that you're doing to get to those numbers you need to get to?
Sure,
Because
yeah,
I'm assuming it's more than just the walls.
absolutely. Yeah, there's a lot of different factors that go into a passive house and what qualifies for passive house standards. But I'll try to talk about the big ones, and Tim can fill in. But they generally care about your energy efficiency and your power usage, and also the air quality. So that's something that people may not think about when they're talking about an energy efficient home is what's the air quality like. Something that a passive house needs to get right is the airflow and the air seals that go in that house, so that you're really controlling the flow of air, the air quality. So we're doing a lot of things on this house, like beefing up the insulation in the walls and in the roof. In the roof structure, we're going to have R65, which is well above what most local standards are. There's also an air gap test that you have to do to ensure that you have a completely sealed envelope around the whole home. So there's no air leaks. You're not you're not letting any hot air in or cold air out. In the summer, and so that's something that very few homes will have done on them, is to figure out where those air gaps are and to create a seal around them. And also making sure that we have triple pane glass windows, and that there are no weak points in this home where you could lose energy or let air in. And there's a special HVAC system that controls different parts of the home and also monitors that air quality. So I would say those are the main features of the passive house. But there's a lot of science and testing and certification that goes into it.
Tell me about, I'm more interested in more detail about the different materials you used to create this home. So tell me about some of the materials you used for the exterior, the roof, the walls, the framing,
Sure.
insulation, any of those kinds of
Yeah.
things.
Yeah, it's pretty simple, with the 3D printed exterior walls, those are made with our concrete mortar and they're filled in with a lightweight concrete. So all the exterior walls themselves are the 3D printed mortar. And then for our roof system, it's a metal SIP panel. So it's a thermally broken SIP panel. We get about R35 on those roof panels. And then we're providing additional insulation to get to that R65 number. So, 99% of the house is either metal SIP panel on the roof and concrete 3D printed walls, for the exterior walls. There are some, wooden supports and decorations and cladding that go along that front porch, but the home is essentially just metal panels and 3D printed concrete. Yeah.
Yeah, it's exterior and interior on the 3D printed concrete. So uh, there are some 3D printing companies that just do exterior walls. We think that's probably because their cost structure's probably still not low enough to be able to efficiently do interior walls. We have a lower cost structure, so we might as well do interior walls. You get some advantages by doing the interior walls in concrete. First of all, everything's load bearing, so you're just continuing to increase the strength of the home. Yeah, I don't think there's any type of a storm that could ever blow one of these homes over. But also, you all those interior walls are fully insulated, and they're adding to the thermal mass of the house. So the house is like a giant heat sink. So it's really hard to knock it off center when it comes to the average temperature it wants to maintain. So it's really slows down temperature changes inside the house, which increases energy efficiency.
Tell me about some of the spaces that you're planning for the interior of this house. Like, how many bedrooms, big kitchen, what kind of HVAC systems? What do the finishes look like? When this is done, what would I expect to see walking into this house?
This house, we wanted to lean into some of the unique designs elements we could achieve with 3D printing. So it's a little bit wilder than a lot of our houses. On the exterior, it looks, from 300 feet away, it looks relatively traditional. It's got a traditional roof line on it, big wraparound porches. But there are very few straight walls in the house. So the front's got kind of these curves that curve out and back in, and then it's got a lot of the walls on the inside are curved. They're straight where they need to be for where you're putting your furniture, likely, and things like that. But there's a lot more curvature than you would see in a traditional home. So a lot of the unique features, we have some parametric walls that were printed. Maybe we can send you a video of it, but they have these kind of parametric, kind of organic curves to the walls with some kind of unique pigmentation in the concrete. So we're leaving some of that exposed. Um, the we have, for example, that we printed the bathroom. So the master bathroom is like a big room almost that's printed because everything is concrete, so it's already waterproof. So we have this kind of room with a bunch of shower heads coming off the walls and a bathtub in it and a drain in the middle. And it's got, it's round. So there's a lot of that going on in this house. There's a little library that's kind of cool. It's a little circular library where, we have shelving, built in with the 3D printing. So we did a lot of that in this house because we could. And it, we'll see if someone buys it, but I think it's going to be pretty cool.
So another thing I was curious about, and I ask this about a lot of the projects that I do interviews on, even though they're more traditional construction. Um, I'm really curious what the process looked like with the building department. Because obviously, this is not a type of construction that a lot of building departments are going to be incredibly familiar with yet. Um, and when you have new emerging technologies, sometimes it's a little difficult to get through that approval process and get your permit. What did that process look like for this house? Any
This house,
challenges?
no, because we're in the county where we don't have a building department for this house, which is most Texas counties don't have building departments that you go through permitting for. we do have a lot of houses that are in permanent areas, like our Houston homes. And for that process, it really has not been a big issue because what we're building with is monolithic concrete. So I like to say it's kind of a new way of building an old structure. So as far as the permitting people are concerned, this is poured concrete or very similar to CMU block. So we have a talented structural engineer on staff, and he does the engineering and he stamps it, and they look at it. And they say, well, it's concrete, so they don't have much to say about it for the most part. There's little details that we have to work with them on, like the inspection process itself. These walls are open at the top before we fill them with concrete, but if they're when they do their plumbing and electrical inspection, they've got to climb up and look down. So we have to kind of pre-clear that with them. So you have a ladder out there for them and things like that, but it's minor details, and it has not, we've gotten several permits for houses in relatively strict areas, and it hasn't been a big issue.
Okay, so I've never had a guest tell me we don't have to get permits. So like seriously, you can just build whatever you want? There's
In
no
Texas, absolutely, yeah. So, and we have a
wow.
long discussion about how, um, um, it's so funny. I mean, so I would say something about 75% of the counties in Texas don't have building departments. Now there is a building code that you you should follow, which we do, and you should professionally engineer all your structures. But in most Texas counties, there's no one to second guess whatever you want to do. And you would think that this would mean that we have buildings falling over and collapsing, and and giant slums built. It it's not like that at all. I mean, you can go out to a lot of these Texas counties where real estate values are really high and people build beautiful homes and there's no building department, and they're building $8 million homes, and there really are very few issues with the process because consumers are much more savvy than I think people give them credit for. So the consumer is going to ask for a well-built house. The liability is, of course, still on the builder. So if anything happens to that home, we have statutory home warranties here in Texas. So, well, the statutory home warranties have sunsetted, but they become the common law standard for home warranties, so that all homes more or less are going to have an implied warranty, is that it's well constructed and it's not going to have issues. So that liability means that people engineer their homes and they get built, and and we're all professionals here. So um, it is it's less of an issue than you would think, and it does speed up the process a lot in a lot of these counties, which has in turn made Texas kind of an incubator for construction technology and property technology, because there are less roadblocks. If you want to pilot a new construction technique and you want to build a home with it, there's no one that's going to stand in your way other than your own, um, making sure you do it right, especially if you're going to sell that home. But that's the way it is, and that's not just Texas. I think a lot of states are like that. If you get outside of the Californias and the New Yorks, and you go to, um, you know, the middle of the country, the majority of counties don't have building departments, period. So even though there are statewide codes, there's no one to do any type of enforcement. And so what those counties will do is they'll publish a letter that says, we don't have a building department. you know, do Buyers do your own inspections, sellers do your own inspections, and work it out amongst yourselves. And that's what most places do.
Sounds great.
Um, so we ask everybody this question at the end of every episode. And basically what it is I hope that we all hope to live a life that leaves some kind of contribution to make the world a better place. So personal or professional for each one of you, what do you hope your contribution will be?
Oh, that's a great question, but the way I would the way I would count the scoreboard is, how many units have we built? And, mostly in that affordable, modern, and smaller scale, how many units have we delivered? How many lives have we, made a little bit easier, a little bit better, because we're creating this new product, and we're creating evolution of something that we all deal with every day, which is housing. And so for me, it's all about the scoreboard. How many units have you built? How many people are living there? And I hope that that easily reaches seven figures by the time we're done.
Wow, 7 figures. Like I said, go big or go home.
At
How about
least.
you, Tim?
It's pretty similar. So, uh, being an attorney, you push a lot of paper and you litigate cases and you make some rich people richer and some companies richer. It's pretty it's pretty ephemeral. It tends to kind of come and go and then be gone the next day. And I think the same is maybe true if you're developing software or you know services. But when it comes to building homes that you want to be there for 1,000 years, this is very, very solid. So it's a big change in mindset when you finish a home and you say this is going to be there for a really long time because it's all concrete. There's no organic materials in the structure. It's not going to change over the next 100 years. So in that course of 100 years, families are going to be raised there. Kids are going to have their first steps, and it's really a cool thing and a satisfying thing. And that's why in our company charter is uh, that our company is going to be focused on affordable housing. So the big custom homes are awesome and they're really good to show off what we can do, but our heart and our focus is, can we bring the cost of construction down to get it back in line with the cost of everything else so that people can start affording homes again? There's one physical product in the world that actually will long-term increase your standard of living and your sense of well-being, and that's a home. Everything else is on the hedonistic treadmill. So every other product you buy, whether it's a car or a phone or a TV, will give you some satisfaction, some enjoyment for the short term, but that fades very quickly. Homes are different because they're very high up on your hierarchy of needs and your sense of comfort and well-being. If you own a safe and durable home, is something that sticks. So it's something that stays with you. So it's really unfortunate that we've been able to lower the cost of these products that don't give us that long-term increase in standard of living precipitously. So, buying a computer now is in real dollars a fraction of the cost as it was to buy a computer in 1980. But the cost of homes is risen at 2.2 times the rate of inflation since the 70s. And so, and it's same goes for good food. All the things that really matter are getting more expensive, than the things that maybe don't matter as much are getting less expensive. And so we're keenly focused on that problem, and that's how we want to make the world a better place, is to get that back in line so that we can increase this like collective wealth in a way that with the things that are actually going to make us live better.
I love that. Gentlemen, I'd like to thank you both for joining me today. This has been enlightening. Um, I learned a lot more than even I thought I was going to learn so far today, and I really look forward to seeing what you do.